crap and talk about HA proxy and Nginx and traffic and or Caddy.
Caddy server.
Yeah. Here we go. I wonder what this recording's even going to look like when we're done. I don't know if it has like, you know, a mechanism for like gallery view, something. Nope, doesn't. I don't know what that's going to end up looking like. That's too bad. Yeah, when we talked about it, you asked just now, does anybody use HA proxy? I don't know. Like, what happens if we even look for HA proxy? You remember what it was?
Oh, I certainly remember what it was because I
wrote
a book on it. So
wait, you wrote a book on it?
I did. We didn't publish it.
Oh,
we had a fallout with the publisher, and it didn't, because I had when I worked in the video game industry, I had IP requirements that said that anything that I did while I worked for them was owned by them. So in a gap between working for EA and Zynga, we worked on this, and then crap happened with the publisher, and I took the new job, and that meant it would have gotten wrapped up under their stuff. So it's been abandoned since 2014.
Well, look, HA Proxy is still having a conference in 2025 in San Francisco, which is like, you know, sort of some kind of tech hub, you know. And look at these brands that are there. Cloudflare, like I've heard of them.
I mean, I can see that
Yammer, I guess.
I mean, Fastly is built on Varnish. I don't know the current state, but Fastly was 100% Varnish based, right?
Varnish
that's going
to be behind HA Proxy, right?
No, I mean so these all serve the same layer, right? I mean, HA Proxy was originally pure load balancing, but really a load balancer is just a reverse proxy. And so everything in that reverse proxy market is also just an HTTP server, is also just a...
Wait, I thought HA Proxy was just that TCP UDP only layer, but I'm like reading this here and it says like Quick and H2. And so
I'm sure that they've added, HTTP2 and Quick.
You know, here's some Quick and HTTP3 stuff in there. So maybe all of my data is like super old.
Yeah. I mean, if people are still using it, and I'm sure they are somewhere, I just never run into anybody using it anymore. But you're probably seeing it baked into product and behind, built into the infrastructure of product. But it's not anybody's go-to at the early stages anymore, because you get
look at all these log levels, and it's definitely, check this out, it's definitely HTTP aware. I didn't know that at the time.
Yeah.
They've got this other stuff here where they're like, hey, you can fetch out interesting stuff at higher level layers. OSI model shit. Remember that?
Yeah.
Just how to fetch stuff out from HTTP, layer 7 even these days. Big deal.
Mm-hmm.
So that's actually a lot. That's cooler than I never got heavy into HA Proxy. I was like, HA Proxy, it's a thing.
The big problem 10, 12 years ago was that nothing had integrated HTTPS support. So not nothing. Nginx had integrated HTTPS support.
Like Varnish was HTTP only.
HTTP only, right.
You always had to have like a terminator in front.
Yeah, you had to run S-Tunnel, Terminator, Apache. You had to put something in front of it if you wanted to terminate SSL. And in fact, we would do that with ELBs. So, ELB would terminate our SSL, even though ELB didn't have SSL originally. But once it did, that saved us a lot of overhead. That managed that distributed out to Varnish or to HA Proxy, or, in one platform, we used Varnish and HA Proxy both, because we used HA Proxy primarily. We used it as an SQL load balancer. Yes, you can do that. And we used it for Blaze, which was a custom binary binary GPG.
Take your time.
What's the word? RPC communication protocol, right? So RPC. So it spoke heat fire. Heat was the binary version. Fire was was an XML over HTTP. But we had to support both of those depending on the clients connecting, and so being able to do that load balancing for that which today we can do that with in AWS. We do it with an ALB, right? Because ALBs, or you do it with an NLB, right? To do the binary protocols. But
you mean their elastic load balancer?
Yeah. So in the elastic load balancer, they have all these different pieces. The NLB, the network load balancer, would do the.
When I started in this game a cajillion years ago, it wasn't that long ago, but it was still in the 1990s. And I was at Microsoft. I worked on a component of NT4 Service Pack 6 that was called WLBS, the Windows Load Balancing Service. And it basically spoofed every machine in the cluster had the same IP. And so it was like multicasting packets to like however many hosts you had on that cluster IP. They had their individual IP, they had a cluster IP. And then you would just like blast packets at all of them. So you blast your packets out at like up to like 32 nodes in the cluster. 31 of them just say, that's not for me, and drop the packet straight away. And then one of them does its thing, right? It was very good for, things like if you needed the FTP load balance or if you needed the HTTP load balance, it was great for services like that. It was definitely, there was a different solution if you were trying to load balance Microsoft's SQL servers, right? They used that, what was it at the time? It was called Wolfpack. I'm so old. Nowadays, nobody has to deal, not nobody, but nowadays, very few people have to deal with this until you're very big, right? You get into Amazon, you check a box, you get Elastic Load Balancer, right? Is it HA proxy? Maybe. Is it some custom stuff they've done? Could be HA with some custom stuff. And you would hardly know, right? Check the box.
Yep.
Everything seems to work just fine. So that was that. And you were also talking about, so Nginx, you can't use Nginx necessarily for high availability because it's just one box. You don't.
No, it has load balancer functionality too. So you can
one box, isn't there?
Well, it's one box. All of these are one box. In order to do anything else, you still have to load balance in front of them in some way, right? So to make a highly available,
I thought HA proxy was able to do that and basically put itself like two side by side and like fail over.
That is the functionality of. So that originally that was VRP, right? VRRP, it was HSRP, but HSRP was owned by Cisco, so it became VRP, and then VRP became something else. So this is something that you can do outside of AWS. So when you're operating inside your own network infrastructure that supports multicast, that's how you do that. Now, if HA proxy 10 years ago, HA proxy did not have this built-in support. You still had to build that layer on top of it. All HA proxy does is it says, I receive a request, I run it through a selection process and say, this request should go here, 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 based on whatever rules I've got in place. You still have to distribute those boxes and get traffic distributed to those boxes. The cheap way, if you weren't doing VRP, was to, and I know that the Linux kernels have evolved to have some other support for something like VRP today. They've changed the name. There was I believe there was a bunch of legal issues, continued legal issues. But basically what you're doing is you're presenting multiple machines as a single IP address to the network, right? And what VRP would do is there was a heartbeat protocol over multicast that would communicate over multicast to all the machines listening to that multicast address that would say, hey, I'm the boss.
Yeah, that's similar to how like the Windows load balancer works, and there's a registry config for how frequently you want to have that heartbeat go.
Yep. Now, it didn't handle load distribution to your load balancers. So if you had two load balancers running VRP or similar type of protocol, then your traffic is only going to one of them. But if it fails, if it goes down, if the other stops receiving its heartbeat, it takes over. Now it does this by assigning it that IP address. It creates a virtual ARP address
Yeah, you're moving the IP from box A that's failed and moving some IP that existed there to a different one, possibly doing a little ARP cache flush or something in your local Ethernet side of the universe.
Yep.
But if you were fancier, for some definition of fancier, you could have HA proxy. Let's just pick on them for the moment. With like some kind of similar Windows setup to that multicast thing. They both have their multicast IP, the cluster IP, and incoming traffic, hits your edge router, which maybe still, now you have to fail over that thing with other mechanisms, which is out of scope for today. But that comes into your multicast network. You throw that same packet at 2 different hosts, in number of hosts. One of them decides this is garbage for me. The other one decides, according to some hash table rule or something, I like this one, and I know the other person doesn't like this one. And then it just passes through now to your back-end application servers, which could be 7 or 8 different servers, on the back end. And it looks like, and I didn't know this, earlier, I didn't know this 5 minutes ago, but HA proxy with its layer 7 inspection, you could also use it to have your single fancy endpoint on the internet, Edoshio.com, and Edoshio.com resolves to some IP address that's on a network that I control behind my fancy edge router, and I've set that up to be multicast to HA proxy 1 and HA proxy 2, and then they both have really clever rules on them so that when you hit Edoshio.com / something clever over here, it routes to backend application server 1, 2, and 3. And if you hit Edoshio.com / foo, it routes to these 3 over here. And if you do Edoshio.com / ws, it knows that that's probably a WebSocket connection, or probably is smart enough to do like header inspection. So you don't even have to make that choice. And it's like a sub route. Oh, you went to Edoshio.com / foo, and then you tried to do the upgrade to WebSocket. HA proxy just has like some inspection rule, because I know that you can also. I don't know enough about Caddy to know if you can do that. I just now am thinking, HA proxy, the one I had used before. Oh, you can do that. I was looking at these Nginx rules. Nginx is definitely setting itself up as I'm a single box at the front.
Yep.
And I'm just doing SSL termination, very likely. And then I'm routing this on the trusted network, on the trusted backend network, semi-trusted backend network, to hit app server 1, 2, 3, and 4.
Yeah, and it's more heavily used these days. Nginx is we see it less being a load balancer and more as just a proxy server to a local, less featureful. So we'll see it in front. We see a machine. This might be a Docker container running Nginx with, say, UWSG behind it, or UWSGI, right?
Sure, whatever that one is. I know what you're talking about, though.
The Python, the Python integrated web server, the one that everyone uses that's actually scalable. That one, but it's not a full featured web server, right? It speaks HTTP, but there's not a lot of
speaks HTTP, like sorta.
Exactly, it speaks HTTP enough, but you don't want to put that directly in front of your customers, or more importantly, in front of your adversaries.
Here it is. UWSGI.
UWSGI. That's the
setting
one.
up for load. Nginx here saying they can do the load balancer for fast CGI, UWSGI, SCGI. Says you can do memcache, gRPC. I know that Nginx was also having some features to do mail proxy, which I always thought was like a weird feature set. Oh, you dig around in their config and you'll see that there's
I don't remember
mail,
but yeah,
never used it, right? I've only ever used Nginx, like the things I would do typically, right? And I'm at smaller scale, so I rarely have to worry about HA, or when I'm in that zone, I'm already in AWS, I'm already in Google Cloud, and I point my IP to whatever load balancer I've constructed in their universe, and I'm sort of fingers crossed. I checked the necessary boxes here for availability zones, etc. I'm hoping that my DNS is good for that. I'm hoping that my DNS integration is good for that. I'm hoping their multicast is good. I'm hoping their configs work okay. And it, it generally does most of the time. But then when we're hosting in there and we want to have reasonable performance, but we still want things to be, air quotes, bulletproof, right? You put Nginx on the front, give it some caching so that all that's, so it's load balancer, then it's Nginx, and with a generous cache. So any of the static assets that get served from the back end can now just stay pretty hot in Nginx. And then when you do your app requests, those get load balanced to some back end, which is, in some of those cases, the Nginx on the front end, and it looks like a single user experience to the client, but one of the back end requests is like landing on, Apache with PHP, and the other one's landing on a Python. And well, there's this one little component that we've got where the WebSocket is involved that routes to Node.js thing. But then there was this other special WebSockety spot where the node wasn't performant, so we had to do this other one special thing in Golang.
Right.
And now you've got 4 or 5 different back-end services on this, what they used to call like the DMZ, right? Remember that one?
Yep.
And then ELB or something. Nginx is now really just sort of like my app router.
Right.
And I've always found, I do not think that, I find the Nginx config file a little arcane.
It is. It's also extremely limited. If you ever look up the religious arguments around using an if statement,
don't use if, because if is good. Like if is like go to, right? Some velociraptors are gonna come and get your ass, dude. So that's for sure. I've read it like twice because I found myself needing to do that.
If you have the need to use an if statement, stop. Back up. Pick up OpenResty. So OpenResty is Nginx with a Lua plugin, and now you can write using Lua. You can create your rule sets and make your actual if statements and all the things because you have a full programming language at your disposal instead of their extremely limited configuration language. When we used Varnish back in the day for this type of thing because we needed to have intelligent decisions happening in our configuration structures, right? Yeah. And Nginx didn't allow, they had this thing called an if statement that was not what you think it was. Yeah. And so you couldn't use conditionals, or you couldn't use conditionals in the way we expected to. Later, when OpenResty came around, that really, OpenResty is really just a series of plugins wrapped around. You can do Nginx and plug in the Lua plugin just fine, but OpenResty is the easy path to set it up.
Yeah, I don't know.
And now everything you might want. So in Varnish, we had an inline C, so we could use C in the actual decision logic, right? Using inline C, and of course it's C. Good and bad, it's C. It was awesome because it meant that we could go and have really complex programming logic that would happen. We even built, we would even fork our application, our back-end application, identify high constraint, high traffic, high load pieces of it.
Yeah.
Is in that these are back in Java or these are in PHP, and pull those back, rewrite them, and run them in C in Varnish. So now we pushed that all the way back to the load balance, or to the
forward.
Yeah, we moved it forward, and it was a lot lighter because we were able to strip out a bunch of stuff and write it in pure C. And these were things that were very highly active. One of the reasons that we brought these tools in, the reason we would bring Varnish and Nginx in at all to begin with was the big win was for that caching layer, right? And that's so we would cache static assets, but not just static assets. We would cache API responses.
I'm looking at some of these plugins right here for Varnish. Seems like you could write your own pretty quick.
Oh, yeah.
And there's loads of these examples to pick up. 4 or 5 for picking up you know, IP, geo IP crap, hash IDs, move some vars around, JSON parsing. All right. Where's the one that's integrating email? You know, no application is complete until it's integrating with email, right? It's probably down here somewhere. Points to Redis. Like, what is that for? Oh, this is to put varnish cache in front of Redis?
Well, this is to allow you to use what's in your Redis database, or use Redis as a database for accessing, making configuration decisions, making routing decisions, making whatever. If you're building this configuration layer, so think about Fastly, right? Fastly, Cloudflare, what they're doing is they're receiving a request, for hundreds of thousands of different possible websites into one single cluster, right? So they need the ability to look at that request header, the simple version of it. Let's look at that request header, and it's it's
trying to
right? And it says, where does this go? We can't compile all of that into one little static config file. So we need to look somewhere for that information. So we'll use the Redis plugin to ask Redis, say, hey, I make this database query. Now I have that. Now what servers are currently active? Right? That's the type of thing that you would use that for.
Oh, yeah. Okay. Subnets and sentinels and other interesting stuff that you get to pull out of. I'm looking at the docs for one of these. libvmod Redis. This is just like the docs of what it does.
Yeah, we did like 20 or 30 internal vmods for our game platforms.
So now there's another choice. There was at the start HA and Nginx and Caddy and Traffic, and we haven't even gotten to Caddy and Traffic, like the new dogs. And here we are. Well, HA proxy still alive and viable, and has a conference coming. That's awesome. Nginx is still a good LB, but it's not the multicast accepting front end. Nginx won't do that. HA proxy might be able to do that. Then you go to Nginx to then route to your application. Open Resty is just a better extended Nginx.
If you need,
that's what it says here. It's extended Nginx.
Yes.
It has Lua JIT, Lua libraries, and that makes it easier than the C-level vmod. And now you're off to the races, right? That's their value prop.
Writing in Lua in OpenResty is so much easier than writing in C.
Yeah, it's a little bit heavy for some of that stuff. And, you know, generally the app devs working in a language that is not C, and then getting stuck writing C that is also now inside of some other biggish platform thing with all of the interesting C tricks that they've done. You know, like I've not done a mod for Varnish, but I've done one for PostgreSQL in C.
Yep.
And you know, you have to work in the PG's ecosystem, and they have these magic functions that you've got to do with this magic stuff. So, you know, and I don't use C every day. So it's like, oh, well, let's remember C. And fortunately, a lot of the stuff from 20 years ago is the same. Swish, but was understood. So then now it's 2025. And you have a greenfield project, and you've got HA proxy, just throw it in Amazon. Assume that just throw it in Amazon and Google Cloud or Azure is out. But now you're making your own choice for your own. You just got your own rack with your edge router at the top. Maybe you've even got access to BGP. So you're like the full network god, right? And you get to put, well, what are we going to do right after our edge router? HA? Would you do traffic? Would you do caddy? Would you, and like, I'll just open some pages here. I finally turned the screen sharing on. We were talking about the stuff, and I thought I was sharing my screen, but it wasn't, dumbass. So that's sorted now.
I would do caddy. If so, on the front of it, where I'm terminating SSL, I would do caddy. Because caddy has very tightly integrated Let's Encrypt support.
So does traffic.
Does it?
Both of those will do the, Acme fetch me a certificate.
Right.
Kind of
and it's fully
easier than
integrated.
it will for like Nginx or Apache.
Like for Nginx, you have to bolt in external scripts that run, and then you have to actually restart Nginx to pick up the changes, right? Because it has to rewrite the Nginx configs, and Nginx has to restart. There's no way to even do a hot reload on it. So Caddy, it's fully integrated. It's literally a single line of config to set up your Let's Encrypt stuff.
Sure, but is Caddy going to give me so the thing I like, or the thing I'm looking at traffic for, is because I want the smarter app layer router, which is for me SSL terminate, and then the routing rules that I got to construct in Nginx is they work. I wish I could make them smarter and a little bit easier for me to understand. I found traffic because lots of people using the Docker universe point to it. You can see like loads of these Docker compose files have like one or more things going on, one or more services in there, but the top level service of it is like, oh, we have traffic running. And then there's these like very complicated, I'm sort of over my own head with it sometimes with the traffic config. Like you can make these magical labels in the Docker universe, and then somehow those magical labels on this service tell the traffic service that thing is available with this router. And
it's just internal DNS. If you look at the labels, it's just internal DNS, right? It's inside that split horizon DNS.
Yeah, well, that's cool and all, but then sometimes you're like, it tells you http.router.something, and sometimes you're like, is one of these the required name, or is one of these like my nice little variable that I could pick my own name on, and then have to remember to be consistent throughout the rest of the use in my Docker file. Like I don't always follow that, but
I haven't looked at traffic in a long time. When I did, it seemed overly complicated and cumbersome in the config.
Caddy can do the routing.
Caddy can do all your basic reverse proxy functionality. Basically, all the same
stuff I'm ever doing.
Do with Nginx, right? Say, let me look at a host header, or let me look at a port that I came on.
I look at the host header to route to the back end, right? Because app.something versus API.something goes to, this or this.
Or look at the URL. So I take,
I want to look at part of the path because app.adocio.com/foo goes to like the foo handler of the app, which is our legacy code base that's running on this old crusty infrastructure that we're working on getting out, but it's not out yet. And then if you go to app.adocio.com/bar, well, that's like the new feature set, the updated UI or whatever nonsense. And that needs to route to the other app server because we have a totally new app stack that's running that, because our legacy stuff, we didn't want to keep grinding it forward, right? That tech debt is too much. Let's throw it away when we can, but at the same time, let's have a front end that still exists, right? The sort of less contrived example, right? app.adocio.com/v1, goes to the prototype code. api.adocio.com/v2 goes to, the better one. And we can just route at the front end with Caddy or traffic or Nginx or whatever. You think, I haven't seen it, but maybe this is just like momentum that is making that happen. I haven't seen a lot of Caddy in the container suite.
I mostly ever see Nginx in the container suite. So it's interesting that you're seeing traffic.
Yeah, so these are like a container suite where it's, I'll pick on my side project, OpenTHC. That when you run that, you don't just run app.openthc. It's not like microservices per se, but you need to connect to some kind of compliance reporting engine, which is there. And then there is other parts of the project that are intended to be, well separate from the primary application.
They're services.
Front end. So when you run it locally for yourself, you've got you've got your compliance engine that's doing all of this logs and compliance. and then you've got a POS front end, and then POS front end inside your shop, you might want to do one thing. If it's exposed to the internet, when it's like a delivery driver, they want to do something else. And we've been working on the Docker suite with traffic at the front. And for the host names, it's just routing it straight into the container with the same name. App goes to app, POS goes to POS, this goes to this. And then you can say, oh, well, when you're coming in from somewhere else, this path is like restricted if they have their thing on the front end. Or in some cases, there's an even weirder setup where you have a server on the internet VPN'd into your office, and the people on the internet, delivery drivers and stuff, they're visiting, external.pos.company.com/delivery. And that's hitting some remote server way over there that just goes through the little VPN tunnel to the internal box, and that's not really traffic that's handling that, except that I suppose you could set up some route like that. But that's where I said, oh, I have multiple hosts in my Docker. I need to find something. And the internet sort of routed me to just use traffic.
Gotcha.
But if Caddy is doing that, and I see like Caddy file, request matchers, client IP, header regex, path, query, protocol probably lets me, it does stuff with HTTP or gRPC and HTTP2. That's pretty handy. Named master wildcard, do something with the thing. The only one I'm trying to figure out is, here it is. It says common patterns. Doing something with PHP, static file, SPAs, trailing /fix. Ooh, that's kind of a fun. The only thing I'm looking for is like upscaling the request so it knows if you're a WebSocket to send it somewhere else.
I don't know. I mean, I assume it's got some WebSocket support, but WebSockets are a funny thing.
They're not funny. They're awesome.
If by awesome you mean completely breaking your scaling model.
What are you talking about? No, that's why
now we go from
multicast load balancer in the front end. We were just talking about this, bro.
But only
in the front end and infinity number of app servers behind it.
But what you've done is you've locked a client to an app server.
No. Only until my WebSocket fails.
Right, exactly.
which fortunately we don't have to worry about that happen, because we know that's gonna happen, and then they'll just reconnect. Boom, problem solved.
That's only problem solved if the reason that you were implementing WebSockets was because you needed the persistent connection, so that you had live data stored in cache on that app server. Right. A lot of times the reason that we implement WebSockets is because we wish we had persistent connections.
I don't know about this persistent connection, because before WebSockets, you could do server sent events, SSE, they would say. Do some SSE. And SSE, sort of kind of sucked, because you'd have the open client connection. It's a regular old HTTP connection, so it is browser limitations built in on how many open connections you got. And you have the SSE, and then you do have the long polling is happening on your server, right? The client request comes in through your magic load balancer and all that sauce, and then lands on your app server finally, which is like, waiting on an event to get published on Redis, and it's there's some kind of like spin lock, right? Check the status of something if the file doesn't exist, or whatever crap you're looking up, DB, Redis, file, whatever, doesn't exist. Why don't we sleep for 1 second? Feels good to me, right? And then check my thing again, and then check my thing again. And if my SSE loop goes for more than 60 tries, push back to the client, hey, I found nothing this time. And then your client needs to be smart enough, that SSE, session, for lack of a better term, did nothing. Let's reopen it. I think it was before. There was another funny term that folks used before. Ajax was the common term for stuff like this.
Well, I mean, really, what you would use you would use
There's something for blocking long polling requests, though.
Yeah, because I mean, using an HTTP keep alive keeps the socket open, but available as long as everything allows the keep alive to come through, right? So you've made a request, it's keep alive supporting the load balancers and all the path along through in the web server all allow keep alives, and so that's maintaining a socket. So your next request is still a request, but it didn't have to open a connection now, but it is all still polling, right? Because the expensive part of a request is opening the connection, making the request,
That's
receiving the response.
You've got to do that too,
right? And so when you make a lot of small requests, like just a simple "Are you there? Is there data yet?" right? Then if you had to keep reopening the connection, that becomes a lot more expensive.
right?
The nice thing with keep alives is that it's easier on the load balancers than WebSockets. If you scale that up to say 100,000 concurrent users,
right? Because the keep alive is the socket's like a semi-open state or something like this, right. If I remember correctly, right? And then the WebSocket is definitely
a persistent active connection,
right? It's like always on.
Right.
Side note here, I was just doing some digging. Paths for WebSocket on your routes, you would just say handle / something with some rules here in Caddy.
Yep.
And here's some documentation. It says you put a @ symbol and looks like some kind of pattern matcher or something.
Yep.
Which I don't know enough about Caddy on, but it seems like
well, that's your upgrade to WebSocket header that it's adding, right? That's telling the
I mean, this says connection upgrade WebSocket, and I think this is like a matcher that says if the header does this, then your @ WebSocket rule. Again, I don't know the whole details.
That sounds right.
@ symbol seems like something special, maybe a reusable rule. It's like that in other things.
Because your client has to
say handle path, and then you say, oh, and on WebSocket, then do this next little group.
Your requesting client has to support WebSocket. So if it sends and says, if it sends the connection header that it says I'm allowed to do WebSockets, and then you support it, then you correct them too. But
like you do an matcher header connection upgrade, and you've done that. And here's another one from there, like CEL expression must be something Caddy special. But here you have it, and then you get this, and then you would just say like, oh, @ WebSockets, and then now my list of backend servers is my Node.js or my Golang one, because I have this other app that's Ruby or Python or PHP or Cold Fusion, perhaps, things of that nature. ASP 3.0, which now
it changes the scaling. So part of the reason that we use these reverse proxies instead of just going directly to our application server HTTP endpoints,
right,
is to decouple. One of the things that we do is we decouple keep alives. So we will keep alive, clients will keep alive to the load balancer. The load balancer would keep alive to the application server, right? Because we only have a limited number of sockets that we can ever use on a machine, right?
Yep.
We'll just round number this and call it 64,000, right? There's others. Many of those 64,000 sockets are in use, but if your load balancer it's got a socket to the client and a socket to the server, so now we're down to 30,000, right? Maximum connections, because it's got to do both, because it's one-armed and it's got to communicate to the client, it's got to communicate to the server. Now, if we have 100,000 active concurrent users who are doing polling requests, where they make a request, pause for a second, just a second, right? And another client makes a polling request, pauses for a second. Right? We have a fairly scattered, right? We've spread that load, not well controlled, but we've spread that load across a 60-second interval.
Yeah.
So the connection load, those 100,000 connections, are spread across that 60-second interval. If we have 100,000 WebSockets, we have 100,000 sockets concurrent. We have 200,000 sockets open concurrently on that load balancer, which means we now have to be able to pull a load balancer out who's at capacity of sockets. One of the reasons we use load balancers like this are because they're generally more performant than our application server.
They're only doing that one thing, right?
They're only doing that one thing.
Right. The other nice thing that happens when you put them in front and you put like a fail to ban or one of those other rule sets on there is that all the bullshit traffic on the internet dies on a machine that's really just designed to open and close sockets with a very small set of rules, right? So all of the horsepower can be dedicated to just
because a simple connect and reject to your load balancer. You can tune the TCP stack on your load balancer to be more efficient for load balancing purposes. And on your app server, you would tune it differently. The actual application that you launch does things differently. So your load balancer can everything in this class of software can reject a request, connect and reject a request in, let's just call it 5 milliseconds.
Right.
When your application server, your heavy stack, you connect to Jetty with Java, you're looking at 50 milliseconds probably.
Well, I gotta also, when I connect to that back end, because this is my legacy app that's Cold Fusion or PHP or Ruby, that connection needs to then open a database connection to something else behind it.
Right.
So now it's not 50 milliseconds, it's 200.
And this is just to execute the logic of, is this request even something I was supposed to answer?
Well, I got to look up the guy's authentication.
Right. So 404 versus 404. Right, exactly. Right. And then that ramps up. So you mentioned Cold Fusion, one of the the platforms that you license per connection. So how many connections are you licensed for?
There is a reason I was picking on Cold Fusion.
And the default configuration, at least it used to be, was 10 threads. It could only ever respond to 10 concurrent requests at a time. That was the default configuration that most Cold Fusion operated at. So you needed a lot. If you needed those 100,000 users, you needed a lot more, right? So by decoupling that and making that, you decouple and you move that poller, right? You separate that polling service out to its own service that's much lighter. It's running in anything other than Cold Fusion. Even though your core app stack is in Cold Fusion, you say, okay, I've got my poller that says, is this available? And now you do that to your WebSockets too. You connect your WebSocket to Go or whatever. But you do maintain that persistent connection and you have scaling overhead from that. It means your load balancer layer becomes larger.
Yeah. I'm disappointed that this Caddy wiki doesn't have a picture, right? On traffic,
right?
You look on traffic and you get a nice picture right at the front that tells me all the stuff I wanted to do. api.me.com, me.com / some weird shit, and yet another subdomain. So I'm routing by path, I'm routing by subdomain. It shows me the little picture of the HTTPS termination and is like telling me nice things about it too. Dynamic routing, auto discovery for new stuff that's on the back end. I don't know if that's in Caddy or not. Probably, right? Lots of these things are all just, converging at common feature sets, and then one of them has it, and you're like, oh, my current one doesn't have it this week, and then next week someone's like, hey, I wrote a new mod that tells you how to do dynamic route or something, and it gives you metrics, tracing, and logs. Like that's it. And I guess they're saying, look, we're an application proxy, which really maybe means they're HTTP and similar proxy. But Caddy's also that. But traffic isn't a web server at all. And Caddy
it can serve static assets. It can serve static assets. It can serve a tree of files out of a directory.
Traffic does?
Yeah.
You sure?
I am sure.
I don't know about that. It always is. I've never seen an example with that one. And it says configuration discovery. I don't know. Frequently asked questions.
Does it have a caching layer? I don't think Caddy has any kind of significant caching layer either. But
I mean, that's the next thing. caddy file, reverse proxy, something. There's got to be a mod.
No, okay, I was wrong. Traffic does not serve static files at all.
Boom, told you so. I just love saying it, so I had to do it. Yeah, traffic, I think, is just this routing thing, and I don't think it does, or at least I've not seen it doing any kind of caching stuff either. You would have like, maybe you have something like just operating at the TCP layer, HA proxy, getting the multicast, throwing that away. Then your HA proxy lands to your traffic / caddy app routers, which then may route some stuff through Varnish, right? Keep all my hot static assets in Varnish. And then I have my app servers behind that. So we've now drawn like a fairly complicated thing. I wonder if we can get a diagram of that on Mermaid. You ever use Mermaid, man? I love this damn.
I have GPT create memory diagrams a lot. Yes.
You make GPT do it?
Yes.
You don't like to just overthink it yourself?
No.
No? Sod that, huh? I don't know. Let's ask it. Draw me a mermaid. I'm not even going to spell check my shit. Draw me a mermaid diagram. HA proxy, multicast, front, edge. How about edge router? Passing to traffic, app router, which passes to which proxies. Let's make sure we're using good words. Which proxies to for app servers, a Varnish cache, Apache plus PHP. What other dumb thing? Oh, Node.js WebSocket, and Golang static, Golang HTTP and WebSocket server.
Sure.
What would this be? The entity relationship diagram, or
I would let it figure it out.
That's diagram. Let's just say diagram. Give me a fucking diagram.
You gotta tell it to write the code for Mermaid Live. Or wait, what's it doing? Oh, it's generating
a diagram.
I think they may have
structured, baby.
I think they may have added built-in Mermaid support at some point recently.
How could you not? I mean, it's like right there.
No, that's Dolly for you.
Oh man, that is actually a very cool diagram.
It is. Now tell it
and enhance on the. When this is on the YouTube, like this one actually looks cool. What's this thing over here? It looks like it's a tragedy.
It's a strategy. It's an operating server.
Operating server, and it's a tragedy over here. Like sometimes there's these front end systems behind something in the back end that is a tragedy.
I like your subwoofer stack over there, though. But tell it to write code for Mermaid Live. Yeah. There you go.
Oh man, that is hot. Let's see what that looks like on Mermaid. That's pretty cool, except that really I need to have like HA proxy 1, and we still have to have like another top level thing.
Tell your intern.
Tell my intern.
Don't fix it yourself.
What do we do here? We say no. The HA proxies are side by side behind an edge router. Then HA, then traffic, then in number of traffic, spelling, and then the for infrastructure, FRASTRUC systems. Subgraph. What the hell is this? Proxies to weird ass names. One of the things I was just telling folks is like this thing comes up with some weird names for your variables that you
That has got some relationships.
that actually looks like how I feel like that should look.
It's probably not wrong. I mean, it's you
Well,
know.
I have my multicast edge router, and that hits me to my HA proxy 1 and HA proxy 2. And then that routes me to my back end split, right? You can see HA proxy 1 and 2 both will take their connection to traffic 1, traffic 2, or traffic in. Like that was very nice. It knows that we could possibly go more. And then I do not know how else you would have it without hell of lines connecting 3 traffics to 4 different back ends. You're going to have lines crisscrossing each other all over the place. I wish you could make it do a straight line.
Ask it to propose a full production architecture for this as a mermaid diagram.
This isn't it?
It's a start. I don't know. Is it? Ask it. Ask your intern.
Well, now what do I ask it?
Say you want to make this production. What are we missing? Ask it what we're missing.
This is good. What's missing before we could put this ARCHITEC tier in production? Before you should consider this shit. Ensure multiple.
Look at that. Kubernetes. Oh.
Well, yeah, that's for auto scaling.
That's for down here. We're just building network architecture. Come on.
But this is for your HA stuff. HA proxy should be an active. Okay, I mean that wasn't explicit. We didn't say that, but that is what's shown in the diagram. At least I thought it was.
ChatGPT even called out VERP or keep alive D.
Yep. Use a firewall, and then it suggests Cloudflare or something like that. Not what I would choose. Put some logging, Prometheus and Grafana, all the stuff you know. Ensure varnish cache is tuned. Yep, it's always been a spot where you've got to tune it or it doesn't work like you want it to. Ensure that Go and Node can handle a lot of traffic. Maybe start using a message queue. Told me Rabbit. Wish it would have just, I wonder why it suggests like specific things. You know, here it says implement failover, and then it tells me like use Slack or PagerDuty.
Right.
You know, it's routing me to brands. And I wonder like, oh man, I guess there's some brands because you don't have to use Slack. You could have Discord. You could have the other one, the new one I saw yesterday, Revolt, or my personal favorite, Mattermost, you know, and they're not even mentioned here. That's unfortunate. PagerDuty's in there, but what about sending the SMS directly through Twilio on your own? Not mentioned. Here's how to do some CI/CD. Oh, you got to have that? I mean, that's all cool, but I feel like that's GPT getting a little bit out of scope for is this here. But definitely your multicast edge router, you know, you don't want to have, we've moved the single point of failure all in the diagram all the way to the multicast edge router, but there's another problem there that's probably not for the site reliability team, and it's probably not for your like DevOps team.
But you do know, because your goal here is to build a resilient architecture, you need to communicate with whoever's working on that and understand what they have, what their limitations are, right? How that their failover works, because their failover needs to match your failover options, right? And once you build this, you should start pulling plugs.
This is this is nice, you know, like, although to get a lot of stuff like this, you know, I can see why folks just slide into AWS or GCP and like, let me just check a couple of boxes and move this slider up to high availability, you know, freaking done. Anyways, this was a great jam session. I think, you know, this was our number 1 of 1. I'm going to probably just post it as is online. I don't know. I was trying to get my Apple account set up so I could get something there for podcasting, but I did not even have an Apple account in 2025. And then when I was trying to sign up, it was like, we can't text your phone number. Maybe Apple and T-Mobile are mad at each other. I don't know. I'll try that again and we'll see what that turns into. And, you know, maybe we'll try this again Monday-ish or something.
Sure.
So
Let's do it.
appreciate it, man. This was cool. Where is sorry, I gotta press some other button up here.